Hey, it's Mr. Saltano, and this video is going to start off our solutions unit. So the first thing we need to do is sort of review what exactly is a solution. So you may remember that we use solution as another term for a homogeneous mixture. They're the same thing, and we said that a homogeneous mixture meant that the mixture was evenly distributed. So for example, if we look at this solution down here, this homogeneous mixture, we can see that the light blue is spread evenly throughout the whole beaker essentially. All the liquid seems to be evenly mixed. And you may remember from bio that a solute is the particles that are being dissolved, and the solvent is the medium that's doing the dissolving. So for example, to make this solution over here, we had some blue crystals as our solute. The solvent is the water, that's what's doing the dissolving, and they combine to make the solution. Another example is salt water, right? So for a salt water solution, the salt is being dissolved, so that's the solute, and the water is again the solvent. You may also remember that we said if water is the solvent, that it's an aqueous solution, right? So another term that we've been using. So let's take a look at how this happens, because it's going to happen differently for different types of compounds. So for an ionic compound, any kind of soluble ionic compound, so in other words an ionic compound that does dissolve in water, it's going to happen this specific way. So let's take a look at how that actually happens. Okay, so we're looking at, right now we have a salt shaker, sodium chloride, and in a moment we're going to sprinkle some salt into the water and see how it dissolves. Just be aware that the legend up here is the pink is the Na+, and the green is the Cl-. And we know that inside this salt shaker right now, the Na+ and Cl- are combined into the ionic sodium chloride, and they're neutral, right, because the charges have canceled. But watch what happens as we sprinkle it into the water. So they're stuck together. And as we put them in the water, they actually separate. And this separation is something called ionizing. So they've actually ionized. Rather than being the neutral NaCl that it was in the salt shaker, it's now broken down into Na+ and Cl-, and those ions are free floating, right? Those cations and anions are free floating in the water, and they're separated now, and they're charged again. So let's take a look at what happens sort of if we zoom into the water more specifically. So here's a bunch of our water molecules, and I'm going to highlight our partial charges. Remember that we said that oxygen is a partial negative, which is shown here, the red, and hydrogen is a partial positive, which is shown here in the white. And if we add the salt in, we're going to take a look at what happens. So here's our salt. Okay, so a couple of interesting things. So let's take a closer look. If we're looking at the Na+, right, our cation, our positively charged ion, the partial negatives of the surrounding water are attracted to the plus of the Na+, essentially. So the water is actually changing the way it orients so that it surrounds the Na+. This is actually helping the Na+ dissolve. And it's doing it so that the oppositely charged negative oxygens are connected to the positive. So opposites attract, right? And then for the Cl-, the opposite is happening, where the partially positive charged hydrogens of the water molecules are actually orienting themselves toward the Cl-. So we're looking at the same thing here, but a little bit more clear, and we can see again that essentially in general what's going to happen is when an ionic compound dissolves, what helps it dissolve is the water surrounding the ions, and the oxygen, the partially negative oxygen, is always going to orient itself toward the positive ion, in this case Na+, and the partially positive white hydrogens are going to orient themselves toward the negative ion, the anion, right? So in this case it's Cl-, and that's going to happen. That's how ionic compounds are going to dissolve that way. Another type of compound that's going to dissolve well in water is molecular compounds, right? Certain polar molecular compounds essentially are going to dissolve in water. And what we're looking at right here, this is a sugar molecule. So these two rings are part of the same sugar molecule. You remember from bio, it's a disaccharide. And we're looking at the water molecules doing hydrogen bonding. So these blue squares just represent a water molecule each, and the dashed lines are the hydrogen bonding that's happening. So that's helping the sugar dissolve in the water. But something else we want to be aware of is, let's take a look how this molecular compound dissolves. Okay, so we've got our sugar shaker ready this time. And we're looking again, we're going to be looking at the atomic level. And so watch what happens in this case. So we pour our sugar in, we have clumps of sugar. And even though we're dissolving it in the water, the sugar clumps, the molecules, actually do not split apart. So the molecules were connected and they broke apart from each other, but a single molecule is not breaking itself the way that sort of an ionic compound does. When we looked at the ionic ones, it was ionizing, the NaCl was literally breaking in half and splitting, whereas molecular compounds that dissolve, like sugar, actually stay intact. So another way of looking at it is if you've got a metal and a nonmetal, that's going to split into ions in water, and if you've got all nonmetals, the way we have this formula for sugar, it's going to stay together. So let's take a look at another actually important piece of that that's going to happen. So right now we're looking at our macroscopic view, so we're not really zoomed in as much anymore. And I'm going to take this conductivity detector. This is going to detect how well the water solution is conducting electricity. So right now there's nothing in the water, so I'm going to go ahead and place that in. And no light, right? The light bulb is not turning on. So let's see what happens if we add the salt. So as we add more and more salt, it looks like the water is conducting electricity better and better to make this light bulb start. So that's why ionic compounds are electrolytes. So remember electrolytes in your Gatorade that we've talked about before? Ionic compounds form those electrolytes. That's what makes them different than molecular compounds, one of the things. And so that's why we get that term, electrolytes. They conduct electricity in water. If we try this again, removing the salt, and we put in sugar instead, so let's sprinkle some sugar in. Sugar is what's called a non-electrolyte. So sugar is not going to conduct electricity. So molecular compounds are typically non-electrolytes. So if we're looking again, ionic compounds are going to be electrolytes. They're going to conduct electricity. See how our light bulb is on here? Because it's split, the ionic compounds split up into its ions, plus and minuses. And molecular compounds are going to be non-electrolytes, or they're not really going to conduct electricity. The sucrose did not split up, it did not form ions, and it stayed as whole molecules. So a non-electrolyte there. Another important distinction we're going to be talking about in this unit is concentration. So concentration is a measure of the amount of solute that is dissolved in a given quantity of solvent. And you could have something be concentrated or it could be dilute, right? So concentrated means there's going to be a lot of solute present, and dilute means there's not going to be all that much solute in the solution. So here's the concentrated solution, and here's the dilute solution. Let's kind of take a look at that another way. Okay, so here is our drink mix, and right now there's just water, there's nothing in there. Here's our sort of Kool-Aid powder we're going to put in to make the drink. And if we add a little bit of drink mix, right now this is relatively dilute. So there isn't all that much solute in there. Now if we continue adding a lot more, so keep adding, we notice that the concentration is getting more and more and more. So then this is actually more concentrated than what we just looked at. And dilute and concentrated are relative terms. So originally there wasn't all that much solute, so it was dilute. And now, wow, look how dark that red is. This is actually concentrated now. So it's just how much solute you have. A little bit's going to be dilute and a lot's going to be concentrated. So what you really want to do is take these vocab terms and start to study them. There's kind of a lot of unique vocab in this unit. But that's it for now for the start of the solutions unit. Thanks for watching. And remember, chemistry is everywhere.